Okay, now we are done with the setup of the Linux environment. Now we will start the setup for the cadence. So the first thing I will do is type dot slash S45. Basically, try to run S45 file as a command. That's why, so we need to do dot slash means in this folder and then slash, right? I will also put an ampersand at the end. Ampersand means that I'm going to bring this into as a background job so that I can continue to use this terminal even it pop-ups with another GUI, right? So I press enter. And then this terminal pop up, right? So Virtuoso has started successfully. Now, the first thing is that I need to create my own library. The library I'm going to use for the design. However, I cannot create from scratch. What I'm going to do is to use the library provided by the Cadence, right? So I'm going to go to File. I said it wrong. It should be go to the Tools, Library Path Editor, I guess, right? So then it will bring up all the library that I have, right, in this folder, in this directory. So I see that I already have the 45 nanometer library already. If not, if you don't have this, then let me show you how to do it. I first try to right click and then delete this library, right? I just want to show you, right? Otherwise I have it already. Then I right click, I say add library. So I'm going to go up to the folder, right? So I do you see that I keep clicking the dot sign? Means go to the upper directory, like when we're doing dot slash, right? And then I go to, and then I go all the way to the top, and then I go to the application file, apps, right? All the way, you just keep clicking, right? And then you go to apps, and then you go to cadence, and then now you will try to find the GPDK, right? And under GPDK, we're going to use this 45 nanometer technology. There are many other technologies like the FinFET 180 nanometer, 0.18 micron, which means, right? And then we are looking at 45 nanometer, right? These are all the generic library provided by Cadence, and this is the path. I click on it, I say I want to select this one, and then say OK. Right, so now you see that the same library I showed earlier appears again. Okay, so I'm going to say File and Save. Okay, so now I imported the Cadence library. I put in the path that I can search. Now I need to create my own library. So for my project, so what I'm going to do is go to File, click on New, and then Library. I'm going to create a new library. Now, however, I may call this Lab 8, okay? But I already have a folder called Lab 8, so I will call it Lab 8. How about Lab 8 Test, right? And I will choose Attach to an existing technology library. That is the TSMC 65 nanometer library. So it is going to attach it to it. And then on top of it, we are going to create our cells, our design, right? I will just say, okay. And then we tell it which one I want to attach to. I choose GPDK 045, and then I say OK. Right, then it has successfully created my library. Now with this, I can start doing my design, right? So I have the library, then I will go to File, I say Cell, and then I want to create a new cell, right? So I say New Cell View. Now, I put in the Lab 8 under test library, right? But I'm going to call this, I just call it the transistor. I can call it transistor. So my goal now here is to try to understand the property of the transistor. I want to find the GM and R out, okay? So I create a transistor. I use open with different tools, right? By default is schematic. Yeah, let's just use schematic, or maybe schematic XL. It doesn't matter, one is like newer. and then you say OK. Okay, so now you see this cell. I'm going to make it into maximum screen, right? Maximize it. So let's look at the menu, see what we want to do, right? So in the menu, the first thing I want to do is to just create a cell, okay? And with this cell, I'm going to set up some parameter, do a simulation. The goal is to find out what is the GM and also the R out, right? Do you remember what's the current gains of what's the voltage gain of a common source amplifier? It's like negative GM R out parallel RD, right? But we need to find the GM and R out first, and that's why here I'm going to show you how to do it, right? But this is an iterative process. This class is mostly about how to use the tool, so I will just give you the answer right away without iterating. Right, iterating means keep changing the size of the transistor to get the GM we want. Okay. So now what do I do? The first thing is that I need to add a transistor. In order to add this transistor, I need to say which library, right? We're using GPDK, right? It comes from that library. Okay. So I'm going to browse, and then the one I'm going to use should be MOS 1 volt low voltage, right? When I click on this, you see that a property screen pop up, right? You see the property screen right here, right? So you say that this is a transistor with length equal to 45 nanometer. Its total width is 120 nanometer, right? And it also tells you all the parasitic capacitance. We won't go into details, right? The point is now, with this, I need to choose symbol, right? On the right, choose symbol because I want to put a symbol here. Once you do that, when you move mouse to this canvas, you will see that the transistor here, okay? And you just click the left button of your mouse, okay? Now it is small. What I'm going to do is press the F key, then it will zoom in, F key, okay? And you can use Control Z, what? Control Shift C maybe. I forgot. F and then Shift C, right? Shifts. Okay, it's a little bit confusing. Shift C, right? So is to before I did, sorry. Okay, that's one thing I keep doing mistake. Now, for example, just now I click this arrow, this button, right? Then it may go into a certain mode. Just please press escape before you do the shortcut. You definitely can click the magnifying glass to zoom in and or zoom out, right? Or zoom to fit it, or zoom to a region, right? Now I can click this one to zoom out. But you can also, but if you want to do the shortcut, just press escape key. Make sure that the cursor become an arrow, and then you do Shift Z, right? Then it will zoom out. Okay. If you press Control Shift Z, Control Shift Z, right? Then it will zoom out. Okay. And I say Shift Z is zoom in, right? Just play with it. Okay. Now, if I press F, then it is full screen, right? So I want to add other components. So I'm going to press Control Shift Z, make it smaller. Okay. And what do I need to add? I want to add voltage source, I believe, right? VD equal to 1 volt, VG equal to 0.6 volt, right? So let me add a new element, right? I say browse, and then now I'm not using GDPK 45 because this is the technology that they make the transistor, they make the of TSMC, they can make the transistor on the chip, but they cannot make any voltage source or current source. Now we are doing simulation. We need to have a model to put our voltage source and current source. And we are going to use this analog library because this is not a real stuff. This is just simulating what we are going to apply to the chip later, right? So I choose the analog library, which is not a part of TSMC. Then I look for all the way to VDC, or you can search here VDC, I believe so. Do I do it? I think it should be, yeah, VDC here, right? And then I just highlight it, and then I put here. I move my cursor to canvas and click the left button. Okay, it won't go away. I click another one, so that, and then I will press the escape key. Then it will be gone. Okay. Now I need to wire them, but before that, I actually also need to add a ground to it. So going to the same library, you can click here also. I just go to browse, and then you search for GND, the ground, right? We need to add the ground. I click on ground, and then put the symbol here. Okay, now we can connect them. To connect them, use this connect icon. I click on this, right? Then I first connect. I click first left click. And then you will have a 9 hanging, and then you go to another terminal, click on this, then I have 1. I also need to left click here, and then just draw it to here, then I have 2. I'm going to click on this one, right? I need to connect the source to the ground also. Now I don't want to connect them together because I remember Cadence will give me error if I have a node that is connected to 4 lines. Okay, so they're still the same terminal. How about the body, right? We did not discuss body much, but as we discussed in the high frequency simulation, the body in our class is usually connected to the source or connected to the ground, right? So I just connect them together. Now I connect the V1, which is the gate voltage, to the gate, and then the drain terminal to V0, which is supposed to be the drain voltage. Okay, now let me check again what we want to do. I need to set VD equal to 1 volt and then VG equal to 0.6 volt. Okay, so I'm going to click on VG, right? I click on it, it's highlighter. You can just right click or just type Q, right? You can right click and search and click on properties, or you can just click on it and then say Q, right? You left click, and then when you highlight it, you say Q. I just put 0.6, and then I say OK. And you do see that the VDC is now 600 millivolt, right? Do the same thing. Click on the drain voltage, right? And then type Q, right? Or right click and choose property. This one we want to put it 1 volt. The reason we do this is that I want to know the GM, the transconductance of this transistor under different situation. Okay, of course we don't have the time to iterate, but I just want you to be aware of this. Okay, now let's see what we need to do now. We have done this, and then we are going to run a DC simulation. Okay, my goal is to get the biasing condition, right? So first of all, you need to check and save it. Check and save. You can go to File, Check and Save, right? Hopefully there's no error. If there's some warning, you need to fix it. Okay. Okay, now we need to do the simulation. You go to Launch, and then ADEGXL. Create a new view. Okay. Transistor, and it's going to use ADE instead of the schematic. And I have something before, so you overwrite it, right? So now this is the bench, right? On top, you have 2 tabs. One is transistor, one is ADEXL, right? You can toggle. Now I need to add a new test, which is a simulation. I expand it and click to add test, or you can click here, right? I double click, and then I choose transistor, because transistor is the name of the schematic I had drawn, right? So my goal is to do the DC simulation, and I just want to save the DC operating point. So I check this and then say OK. And then I can just go ahead to run it. I click on this, and then you see that it is running, and then a window pop up, right? It will give you the information. And now you see that it says Spectre completes with 0 error and 1 warning. I'm not going to look at the warning this time. I just close it. Now go back to the transistor tab here, click on it. I don't have anything, right? I'm going to right click and say annotate and choose DC operating point. Then it gives me the current and also the transconductance. And by the way, this is not a realistic one. However, it's pretty realistic, including you see that the gate current is not zero. It has some finite value, about 0.2 picoampere, right? Because gate is leaky nowadays, right? In a 65 nanometer transistor. Not super leaky, but you do see some currents, right? Now, I have this GM already, but I also want to know the out, the output impedance. So what can I do? I'm going to right click and then say annotate, and then I need to choose setup. You cannot see it, right? So I want to move the schematic up a little bit. So how do I move it? I can use the middle button. If your mouse has the middle button, I don't have. So I'm going to do view, pan. Pan means that wherever you click will becomes the center. For example, if I click this point should becomes the center of the schematic, right? And then press escape, always escape when you want to do something, right? And then I'm going to right click, choose annotate and set up. Okay, then you pop up this window. I want to set up the cell, which is NMOS 1 volt LVT, low voltage, low threshold voltage, right? And I want to add a new operating point. You just double click the expression, right? You can type it, but it has something for you to choose. You can choose FT. Remember the FT we discussed in the class, where you have the current gain equal to 1. Let's take a look what it is, right? And then let me see if we can add one more. It seems that to add it, I need to press this plus button. So let me try. Yeah, I do able to add it. And then here I need to change it to DC operating point. Just double click. And here what I'm going to do is actually there's something called GDS. That is the output conductance. Output conductance is 1 over the R out, R0, small R0, remember? Right? So I'm going to also ask it to show this. Okay. So not sure why I cannot annotate, but let me try first. Oh, FT is NAN. Do you know why? That is because our simulation is just a DC simulation, right? It's not doing the AC. That's why it does not have the information of the FT. Okay, so let me go back. Sorry for bringing you around without anything. So let's go back to here. And instead of doing FT, I'm going to just delete this one, right? And then I'm going to change this to 1 over GDS instead, okay? Now if and then it's just okay, apply to all. Now the 1 over GDS, and let me just press F, then I can zoom into everything. So this transistor, which has the dimension of 45 nanometer, right? 45 nanometer, has the GM of 92 micron Siemens and the Rout of 288 kilo ohms. So finally, let's try a few simulation, right, to change it. For example, what I'm going to do is to right click or type Q, right? For example, let's say, I have one that is let me still use VG equal to 0.6 volt, right? And then let me try 1 micron meter, right? What will happen if I make it 1 micron instead of only 120 nanometer, right? So I put 100 nano, which is 1 micron. You just type tape, then it will work, and then just okay. Okay, so now I go back and of course I need to save it, and I go to here and run one more time, right? I go to the ADEXL, right click on the tab on the top, right? When it is finished, then I close it. I go back to the transistor, the tab here. Now you see that the GM is much larger, 663, but the GDS is smaller. Is that correct? Remember what is the what is the Rout? Rout equal to lambda times I, right? Now we have a larger I. You look at the current is larger than before, right? And that's why the ROut is reduced. But the GM, which is proportional to the I, right? Or square root of I, right? Then you see, it depends on how you write it. Actually, yeah, I over VGS, right, minus VT, right? So it is increased. Right, so this is the table showing that when we change the change the width from 120 nanometer to 1000, right? The GM is increased by this much, right? The RO is reduced, biasing current will increase. Okay, so that is how we know the GM and RO of the transistor, and then we will use this to design a common source amplifier.